A quick overview on setting up your first turbine aircraft. Hey guys, I'm Jonathan from the lighter side of RC. So whether this is your first turbine aircraft or your 9th turbine aircraft, it can be a daunting task to put together, build, set up, assemble an aircraft. Modern technology in the hobby is outstanding, but it can still be an overwhelming process with so many different systems involved in the aircraft setup process. Now this video is being created to mirror the article that I wrote up for the AMA publication. Now as there are so many variations in equipment choices nowadays, I'm going to keep this very general, so your specific equipment may vary slightly. If you do have any questions, obviously reach out to somebody with some knowledge or reach out to the manufacturer to find out more details. That's always my suggestion. So first thing is the aircraft. We're going to be going through this basically the same type of process that we use when we're building an aircraft here in the shop. Now the first thing we think about when we are planning a build is we think about the entire aircraft as a whole. So we want to have as much planned out as possible. I like to do things in systems. So I like to have systems in place for everything available, everything possible, always systems. It helps things to move forward better, move forward smoother, and also helps to ensure that things are done properly. Now before we start an assembly or a build, we like to have all the equipment on hand. I don't like to start a project and then have to wait for equipment, find something else to do. I like to have as much possible planned out here on hand before we actually start the process. From the very beginning of the aircraft showing up and us getting it ready to assemble, I'm already planning out the locations as much as possible for all the different items, thinking about that, and Nez is always helpful as well. So our next step in the process is to set up a model in our radio. Now, I use Jetty as my primary radio system, and I've got a default model built on my radio. Now, the benefit of having that default model built on my radio is a lot of the programming is already done. So when I start a new model, all I do is take that default model, make a copy of it, and that's got a ton of the work already completed. Now, if your radio is capable, I suggest having an individual channel or function for each surface or device on the aircraft. So in years past, with a more limited receiver system, we may be pairing up ailerons, flaps, using reversing Ys. But having those individual channels for each function or surface allows you better control and better setup of your aircraft. Some radio manufacturers and radio equipment manufacturers have very regular updates with their equipment. So in our case, with our Jetty stuff, what we do before we start a project is we update all the devices that are going in the aircraft. So our receivers, our distribution boxes, all of those items need to be updated first so they speak to the radio properly. The primary reason to do this setup initially is so when you're setting up your individual surfaces on your aircraft, or your individual systems, items, whatever it might be, you can plug those servos into your receiver and you can get everything pre-programmed. I like to do as much of my pre-programming with travels, centering, everything possible before we actually even run the servo wire from that surface to the final location of the receiver or power distribution system in the aircraft. The other thing this allows you to do is set up limits with your servos. So in some cases, your servo may travel, let's say 100%, and that 100% travel may damage the surface or structure of the plane, and you're able to reduce that travel down or just adjust the geometry of the entire system so that damage doesn't occur. Now there's many different methods for power distribution. We're not going to go into that. Choose a system that is best designed for you, your radio system, and your aircraft. But more importantly at this point is having an idea or understanding of where our batteries are probably going to end up. So the final size of the batteries can definitely affect your center of gravity location, but having the general idea, maybe from others who have built the aircraft, whether you're putting your batteries in your nose, maybe a foot back from the end of the nose, whatever the aircraft needs, also helps with planning out your systems. Now I'll offer a couple suggestions in this area that I see people constantly struggle with. The first one that came to mind is keep your radio layout consistent. So with my radio layout, my general switches like flight modes slash flaps, gear, gyro on off, main power on off, brakes, smoke on off. They're always the same on every aircraft. So when I'm holding my radio, I can operate those switches without looking down. That's a very important thing. If you're flying, looking at your aircraft, and you have to look down for a switch, and you happen to be flying with 4 or 5 other people, which isn't uncommon at an event, and you look back up, there could be 2 orange planes in the sky, and that becomes a real challenge real quick. I like to keep my setup consistent with every plane. We build a lot of planes for customers here. I build planes for myself, of course, as well, but all of our layouts are the same. So generally on an aircraft, we may have 2 ailerons, let's say. Of course, we're gonna have 2 ailerons. Aileron 1, the first aileron, is always the left. That's just the way I do it. Aileron 2 is always the right. So I always am working left to right. If we have 4 flaps on an A10, we're gonna work left to right. So the far outboard left flap is 1, inboard left flap is 2, 3, 4. So that's the way we keep things consistent. So later on, if we're doing some reprogramming, some radio modifications, we're doing something on the aircraft or the radio, it's very easy to diagnose what lead goes where, what output port does what. Interference is the third one, and that is still a thing even with our amazing radio programs, radio systems, radio technology that we have. It's still a thing. A couple years ago, I lost a beautiful aircraft, a Hispano Aviation Bull. There's really 2 cool things with that crash that I was able to diagnose. The first one is the telemetry systems on our modern day radios. Because my radio was recording all of the telemetry, I was able to go back and diagnose exactly what happened. Now, what actually happened was one of my components was getting interference from the lighting system components, which I had placed very close together. Now, I know many people don't give that a second thought. I definitely do now. It cost me an aircraft, and it was a bit of an oopsie for sure, but I learned something from that, and interference definitely is something to think about. So point number 3 is control systems. Now for most aircraft, this is your servos tied to your power distribution system, which controls your different flight surfaces on the aircraft. Now you want to make sure that your servos are appropriately sized for the aircraft. Also, are your servos able to operate at the voltage that you have your system set up at? So if you're using a high voltage system, which in my mind now I consider normal, but that would be a 2-cell LiPo with straight voltage, are your servos high voltage servos that are able to withstand 8.2, 8.4 volts. Now, one of the most important things on a turbine aircraft when you're talking about the control system of the aircraft is minimizing or eliminating slop on any of your surfaces. Even a tiny amount of play in your surface can do huge damage. As the speed increases of the aircraft, the likelihood of flutter occurring is a huge possibility. Now, one of the things I see very commonly is incorrect hardware, which causes slop. So a perfect example of this would be a nylon or plastic servo arm. Works great in many aircraft as long as you're using a clevis, because the clevis is providing force on the center of that servo arm. Not a good idea to take a nylon or plastic servo arm and put a ball joint on it, because that's giving side force. The ball joint is better suited for a carbon arm, aluminum arm, always a better option. Number 4 is landing gear systems. This gets pretty tricky on most modern jets. The reason for that is there's so many variations. So you're gonna have on some of the big scale jets that are behind you guys right now, we've got a lot of aircraft that still use pneumatic or air systems, and that's the only choice we have for some of these larger aircraft. But many aircraft now are using electric systems. Both are great if set up properly. Now we'll touch on electric first. Many sports jets and a lot of scale jets now are starting to use electric retracts. There's a handful of primary manufacturers, and they all generally make some very good products, and they're very reliable. There's a couple considerations to think about though with electric retracts. The first one is your wires. When you've got a brake wire coming down the leg and it's constantly moving every time the leg retracts or extends. You want to make sure that wire is protected. I'll often take spiral wrap and wrap it around the wire, and this protects the wire every time the gear moves in and out of the aircraft. The other thing is parasitic draw. So when I say parasitic draw, some people may not understand what that is. So what it is when you turn your radio system off, you want the gear controller to stop pulling power from the battery that's plugged into it. Parasitic draw would be that gear controller stays powered up. So usually there's an LED on the controller. Some controllers, when you turn your radio system off, that LED stays lit. Now, other manufacturers, when you turn your radio system off, it stops pulling power, or it's a very small amount from the gear battery. Now, pneumatic systems. To many people, this is like an evil side of the hobby. It's really not that bad if you set things up properly. I've got tons of aircraft that I built over the years that still use pneumatic systems. They're operating reliably. They've got hundreds of flights on them. One thing we're using now in many of our aircraft, especially the bigger ones, this is pretty much the standard, is we're using an onboard compressor. The onboard compressor allows a little bit of insurance. We use it in a bit of a different manner. So what we'll do is we will only use like 1 or 2 air cylinders in the aircraft. That onboard compressor supplies the constant air supply throughout the flying day. Usually when you get to the field for the first flight of the day, you want to use a separate compressor to fill up the system if it's got no air in it. And then from there, the onboard compressor keeps things topped up to the designated pressure. Works amazing. Also a little bit of insurance as well too. When we do a build here, what we're doing is every air cylinder gets pulled from the aircraft, and we're taking a little bit of silicone shock oil. Now the shock oil is simply silicone oil from RC cars, and what I do is put a drop or 2 in those air cylinders. That helps lubricate both sides of the O-rings. The other thing I'll suggest to people is a little bit of preventative maintenance. So if you have a large scale aircraft, over the course of a year, what you want to do is, and this is going to depend on the type of fill valve you're using, but if we're using a Robart fill valve as an example, I will put 4-ish drops in that fill valve and put my air chuck onto it and fill up the air system. What that does is that silicone oil is moving through the various components, keeping things well lubricated and leak-free. Now there are some components out there like the silver valves, I can't remember the name of them, like up valves I believe they're called, and that may be negatively affected by the thin silicone oil. So just keep that in mind, but generally with most air components, it's a non-issue. All right, number 5 is our fuel systems. Like everything else on the aircraft, a well-designed, well thought out and clean system is always key. Many flame-out issues with turbine aircraft can be traced back to poor fuel systems, air in the system, undersized tubing, undersized fittings, so always something to keep in mind. Generally, most kits are coming with hardwall tanks, whether they're Kevlar tanks or fiberglass tanks. A lot of those kits are going to come with their own fuel fittings. You always want to check those fuel fittings and ensure they're appropriately sized. Other important thing to do is always clean your tanks. When you look in those tanks, they may look perfectly clear, you may not see any floaties floating around in there, but there's going to be a lot of residual dust inside that fuel tank, and that can definitely clog filters and fuel injectors in your turbines very easily. So I always use rubbing alcohol, generally 99% rubbing alcohol. I dump about half a bottle in a tank, rinse it around, dump it out, dump the rest of the bottle in there, and it cleans out the tanks and works great. I would suggest not using water, because once you put water in there, it's very difficult to get that water out. The rubbing alcohol just evaporates, and you can just dump it in the garbage and it'll just evaporate. So leak check is another big important one. So once I get my fuel systems all put together, I will pressurize the fuel system just using my mouth, blowing into the tanks. I will clamp off the lines going into the tanks, and I will leave them sit for usually a couple hours at minimum, but I like to leave them overnight. The next day, if you undo your clamps off those tanks and they release pressure, you know that they're holding pressure just fine. Now, if you're a little crunched for time, you can also fill up a sink full of water. You can pressurize the tanks in the same method, and then you can submerge the tanks in the water. Often I don't do that because there may be some wood pieces mounted to the tanks, but that is a quicker way to do it as well. And usually if you find any pinholes or anything in the tanks, the easiest way to deal with it is just use aero epoxy and sand the area down a little bit, and you can patch those little pinholes with aero epoxy. So last thing is UAT or bubble trap. Use a good quality UAT or bubble trap. There's lots out there. They're all great. I'm not going to suggest any specific ones. We use one kind of standard one here at the shop, but they all tend to do their job very well. The one key thing that I do when setting up an aircraft is I will always try and keep the primary or last fuel tank, UAT or bubble trap, and fuel pump as close together as possible. I like those runs to be as short as possible, so very low restriction from the main tank to the UAT and very low restrictions from the UAT to the fuel pump. When you do that and you have appropriate size tubing and fittings, there won't be any restrictions in the system. So ultimately with fuel systems, if I have the option to use larger size fittings, I'll always do that. Larger size tubings, I'll always do that, especially or primarily on the intake side of things. So between tanks to UAT to fuel pump. So number 6 is putting it all together. With all of these different systems installed in an aircraft, it's time to check things over. So I like to do this systematically and go through each of the systems individually, one by one, to ensure that everything is operating correctly. Now, especially with some of our scale aircraft, you may have to do this step, the check over step, before you're actually done putting everything in. And that's because sometimes access to these different systems or items can be very difficult. Often with scale aircraft, you may put a cockpit in place and that cockpit may completely block access to tons of different items. I'll get to this stage of the build where I'm doing my final wiring and check over of everything, and I think I'm almost done, but I'm only maybe 50 to 75% done because this is a huge time suck. So it takes time to go through all the systems, do your different programming, and it's part of the fun of the journey. But at this stage, I find it important to focus on one thing at a time to completion. So if I'm doing all my surface measurements, I'll do all the surface measurements and setup before I move on to a different system or different part of the aircraft. Now, one little trick that I like to do is I like to use masking tape. So during the final setup or build, I like to have a big piece of masking tape on the fuselage and I make my notes on there. So if I have to go back and do this, I'm not relying on my memory to do that. I'm going to make the note on the piece of masking tape, and that's going to ensure that when I get to the very end, I can say, okay, we need to do a range check, we need to Loctite this piece, do this, this, this. All right, now normally at this time, you've done all your setup, all your processes, all your equipment's working, all your systems are working, so it is center of gravity or CG time and test run time. Now, CG is just as critical as everything else that's completed at this point. A wrong or incorrect CG of your aircraft is very detrimental. Now, it's not always safe to consult the manual. What I would suggest doing is there's a lot of build threads on many aircraft. Unless it's a brand new aircraft, do a little bit of research and see what others have had success with. So I'm working on an F-16 right now, a big F-16, and they give a huge range in the manual of 250 millimeters to 280 millimeters. But if you go back through some of the build threads on various locations, many guys are just starting off with 280, and that is still maybe a little bit forward. So it's always important to do your research on CG. Sports jets are generally a little bit more easy, but usually you have a very wide range. So start with something conservative and you can adjust it from there. Very common question that I get asked is, what condition do you do the CG check in? With a turbine aircraft, you're doing it in landing conditions. So very often our fuel tanks are not located right on the center of gravity. So if you've got a 3-tank setup in an aircraft and that first or last tank is way ahead of the CG, and you do your CG with a completely empty fuel system but your UAT's full, when you put fuel in that aircraft, it's going to be very nose heavy. So if you're always going to land that aircraft with a liter of fuel in that front tank, do your CG check or setup with a liter of fuel in that front tank. So you're having a landing amount of fuel in the aircraft, your gear is going to be down, your UAT is going to be full, of course your batteries are installed, the aircraft is flyable and in landing condition. So with all that being done, it's time to get some fuel in the system and make some noise. So generally at this point, when you've done your CG check, you probably put fuel in the system, but when you're putting fuel in the system, obviously you're checking for leaks. Every radio manufacturer, turbine manufacturer is different. There's a lot of similarities, but obviously consult your manuals for your different items on this, but you want to get your turbine talking to your radio system or vice versa, and you want to get those set up first. Also having a helper or two on hand that can operate your safety equipment, that can just help you and be an extra set of hands, is very beneficial at this point. So the first run of the aircraft always gets the air out of the system. So even if you've primed the system, you're going to find there's some air bubbles in there. You may have to do a second start on the aircraft. That's totally normal. Some of our UATs or bubble traps, they use a filter element in them. Those tend to hold on to air. So usually during that first test run, you'll see maybe some air going into the system. All very normal, and that's the point of the first run-up of the aircraft. So I'll tell you my basic way to do the first engine run is I will start the engine, get it to idle, and let it sit there for a while. Now when it's at idle, I'm checking the numbers on the RPM to make sure that we're consistent and we're at the desired idle number. So if it's 40,000 RPM and we're at 44,000 RPM, we want to give the turbine time to bring that number down by adjusting the fuel pump voltage to bring that number to where it should be. So give it some time, let it stabilize at the desired RPM for idle. Then over about a 20-second period, I will slowly bring that throttle stick to max. And you want to do that slowly to make sure that the turbine can learn its various fuel pump, fuel system, fuel tubing, all those different things have changed from maybe when you ran that turbine outside of the aircraft. I'll keep it at max stick for a while until the max RPM stabilizes, and then I'll bring the throttle stick back down. From there you can play with the throttle, familiarize yourself with how quick or slow the throttle responds. If you've never flown a turbine aircraft before, that is one of the huge hiccups that people struggle with, is the throttle delay. Modern turbines are extremely fast, but there is a throttle delay compared to an electric system or even a gas system. All right, guys, this is the 30,000 foot view of how we put a turbine aircraft together. Just a big overview of all the different systems in the aircraft, some key points to keep an eye out for, and hopefully some guidance as to how to go about putting one together. The aircraft, the radio, the distribution system, the servos, the control system, the landing gear system, fuel system, putting all that together are all critical steps in having a successful aircraft and a successful first maiden flight of your aircraft. Now, of course, as mentioned, there are many different methods to laying out all this equipment. There's many different equipment choices out there, so your results may vary depending on what you're using. But my goal here at the shop is when we put an aircraft together for one of our customers, they are able to just do very basic maintenance on the aircraft after their 100th, 400th, 800th flight on an aircraft. I just want them to be able to fuel and fly, and do some very basic maintenance and just enjoy the hobby. So that's it. Thank you so much for watching this video. If you have any questions or comments, you can reach out to me at thelightersideofrc@gmail.com. Thanks for watching, and we will see you next time.